All right, so we are in week 3, which is pretty crazy because for us, that means that we are a quarter of the way done with this course. So hard to believe. But you've made it through 25% of Math 116. So we've done 2 weeks and we've got 6 weeks left to go. I do think that you folks as a group have just brought so much more energy than I could have anticipated for an online remote learning situation, and I hope you know that I really appreciate it. It's way better than sitting and talking to a screen where I never get any responses, so thank you for all your contributions during class. All right, so we've got a couple announcements. So exam 1, everyone's exam 1s should be graded. It does take me a little bit longer than if I were doing like in-person tests to grade. But I do really appreciate most everyone putting things in the PDF form. There's still a few of you where I think something happened technology-wise on your end, but it is really, really helpful to me when things are in the PDF form. It just makes it faster to download. It makes it faster to re-upload, okay? I have not uploaded everyone's exam results. I'm gonna do that after class today. So you should be able to see like what you got on each question point-wise, but you don't have your work back yet, but I'm gonna be sending those out or attaching them to Canvas later, okay? If you do prefer to receive your graded exam by email, just send me an email that says graded exam 1 in the title, and then I'll reply with your graded exam, okay? Otherwise, it will live in Canvas. Exam 1 check-ins. So I noticed that a bunch of you have already signed up for the exam 1 check-ins. All right, so I did set aside some time this week to meet with you folks. And this is a little bit of a packed week for me, so that's why there's maybe not as much availability as there might be on a different week. But if there are times that don't work for you, then email me and we'll set up something outside of that time, okay? This is, let's see, I've never tried this before, so hopefully if you wanted an individual check-in, you were able to sign up for all 3 slots. Did it let you do that, or did it only let you sign up for 1 slot? Okay, well, maybe if someone could get back to me at some point. It's just helpful to know on my end what it looks like for you folks. Okay. Okay. So I did notice that some people put in the chat or not in the chat. Gosh, my brain is not working yet. I noticed that some people put their name and then like parentheses. So if you want a slot all to yourself, maybe you can put your name and then like next to it put individual so that no one else or people know that you prefer to be in the individual time slot. Okay. Maybe that's what we'll do for right now. But I did notice that I think a few of you signed up in groups, which is totally fine. But maybe just go back and make sure, like, if someone else signed up and you wanted to be individual, maybe they just didn't know. So maybe if we just put like individual in parentheses, then no one else will sign up during that same time. Okay. Okay. Are there any questions about exam 1 and the exam 1 check-ins? Great question, Vanessa. So I think your peers can maybe show you a little bit better, but like, do you see this calendar button on the left-hand side? So like there's your account, your dashboard, the courses, and if you click on calendar, mine is going to look different because mine is the calendar for all the classes I'm involved in, but your calendar is for the classes that you're involved in. So if you go down to, let's see, today's the 31st, it looks like the check-in times for today are taken. But so any ones that are in the dark red are already filled out, but the ones that are sort of in the faint red are still unreserved. So you can click on one, type in your name, and then reserve it. Okay. Does that clarify that, Vanessa? Okay. Oh, okay. And so Eric says you can't even see the ones that are already taken. Cool. Thank you. Gloria, yes. So great question. This is mandatory. So this is going to count as your classwork 5. Okay. So it will count as your classwork 5. So make sure to sign up for a spot. I promise I'm not that scary. I try not to be. Okay. So week 3. Okay, a few things about week 3. We are jumping right into chapter 3 this week. All right, so we're jumping right into chapter 3. We've got a bunch of sections to cover this week. Quiz 5 is due on Wednesday, and quiz 6 is due Friday at 9:30. So these quizzes are regular occurrences. Every Wednesday, every Friday morning by 9:30, you should be like, oh, did I turn in my quiz? Because there's definitely going to be one. Okay. You can find them all underneath the assignments. That's where you can find all of the quizzes. All right. It should be in the same place that you located all the other quizzes. Same thing, homeworks are due every Sunday by midnight. So homework 2 was due this past Sunday by midnight, and then homework 3 is due this upcoming Sunday by midnight, okay? So Wednesday, Friday, Sunday are kind of regular deadlines in this class. I've noticed that some folks are missing a few here and there, but just to remind you, it's a regular structure, right? So every Wednesday, every Friday, every Sunday, those are deadlines that you should be expecting to do, okay? And the last thing I want to talk about is just the support. So I know a lot of you are already studying together in study groups, and I think that's really awesome. Don't forget that there are tutoring sessions with Val, so she's definitely there as a resource. There are other tutors in the tutoring center also. So if you're like, I feel like there's a bunch of people here, I'd rather, go with a different tutor, you can still go to the STEM center, like the same Zoom room, and sign up for or request a different tutor. Okay. Also, I do have office hours before class on Mondays and Wednesdays. So we can always meet during that time if you have some questions about things. All right. The one thing I did notice when I signed into WebAssign this morning is there were a bunch of questions sort of like frantically asked at like 10 p.m. last night. I'm definitely an old lady. I'm definitely I do not have my computer on at 10 o'clock at night. So as much as I do want to support you, understand that like if you're asking super, super close to a deadline that's at midnight, I'm probably not awake, and I probably therefore will not be able to answer your question in time, okay? But there is the Ask Your Professor feature, and so that is definitely something that you should take advantage of. Okay, so your trial for WebAssign, everyone should have received a code from STEM Core that pays for your access to WebAssign. So no one should have paid for WebAssign because STEM Core paid for you, but they sent you a code. You should have received an email that gives you a code. So there's that code along with the code that's already on Canvas. Those two together get you access to WebAssign for the whole semester. Jose, did you get a code? Okay. So folks, if you didn't get a code, I'm going to ask you to email Carol Thompson. So she is the lady that at the beginning of the semester, when we did our STEM core orientation, she was the one who was in charge of things like during the orientation. So if you email her, she can help you out with that WebAssign code situation. Okay. Thank you. And Eric says the code was for Red Shelf and it tells you how to get the code for WebAssign. Okay. All right. So if you're searching your inbox, maybe search Red Shelf. And you should find a code. If you do that and you still can't find the code, then reach out to Carol. Okay, I think a few of you are in that boat, so. All right. Are there any other questions before we get started? Sorry, Natalia, did you have a question? Okay. All right, so I'm gonna stop sharing my screen here then. And, oh, okay, yeah, so Natalia, I would reach out to Carol and just explain the situation. She is taking care of more of that kind of stuff for the cohort, okay? Okay. All right, so folks, we're gonna start with 3.8 today, okay? So we're gonna start with 3.8. I think that some of this stuff that we're gonna learn today might still be review for some of you folks, okay? But I know that we move at a much faster pace than a regular class, so it's okay if you feel like, you know, it's definitely moving fast. But I would encourage you to make sure that you're staying on top of things and not leaving things to the last minute as much as you can. I think that's definitely one really good strategy about coaching a accelerated course, okay? So I'm gonna go ahead and share my screen. We're gonna be taking a look at 3.8 first today. All right, so 3.8 is a section called inverses and radical functions, all right? And I'm starting at 3.8 because if you'll notice, we actually started with chapter 4, and so 3.8 is actually the last section before chapter 4, I believe. Okay, so we're going to come back and maybe just kind of generalize what we learned about exponential and log functions, okay? So let's talk about what we know, first of all. So what we know is that if you have addition, okay, and subtraction, that we kind of think of those as a pair, because if I add 17 to something, but then I want to get rid of that 17, I'm going to subtract that 17. Okay, so addition and subtraction, they kind of undo each other. Well, what undoes multiplication? Division, yeah. So multiplication and division, those undo each other, okay? What about if you have a square? Like you square something. How do you get rid of that square? Yeah, we undo that with the square root. Good. What if you cube something? So let's say you had something to the power of 3. How do you get rid of that power of 3? Cube root, good. And the way we write the cube root is we have the square root symbol, but we have a little 3 in the front of it, okay? And the last pair, if we have e to the x, and we want to get rid of that e, what function do we need to get rid of that exponent? We need the log, okay? And can you be a little bit more specific if we're looking with base e? Yeah, we're not just gonna say regular log, but we're gonna say natural log, okay? All right, so far in our academic career, these are some of the most common pairs of functions that undo each other, okay? Now it turns out that every single pair of these are considered inverse functions, meaning that they undo each other. Addition is the inverse function of subtraction. Multiplication is the inverse function of division. Square is the square root, and square root are inverse functions, cube and cube root, and then e and natural log, okay? So for this section, what we're gonna focus on is looking more at general strategies. So we're gonna look at, in general, when we look at a pair of inverse functions, how do we find them? Okay, how do we know how to undo something? And specifically, we're going to look at it in 3 different ways. We're going to look at it numerically. Okay, so like if we just have some numbers, how do we find the inverses? We're going to look at it graphically. So if we just have a picture of a graph, how do we find the inverse? And we're going to finish off with some equations. If we have equations, how do we find the inverse? Okay. Now, in general, when we're studying, I think this is actually a really good way to approach it, which is, can you do it with the numbers? Can you do it with the graph? And can you do it with the equations? All right, the 3 of those together really help get full understanding of whatever topic you're looking at, okay? All right, so let's start off with some notation. So the notation and definition of inverse functions. So inverse functions allow us to undo other functions. All right, so that's kind of what we talked about with addition and subtraction, e to the x and natural log. But in general, if we want to say inverse functions, here's how we write it, okay? So a regular function, we write as f of x. All right, so we consider f of x our original function. All right. And that's a notation we've been using a lot. We've replaced y's. We've said, hey, we're just going to be grown up here and do the f of x, okay? Now, if you want to say inverse function without writing out the whole word, here's what it looks like. F with a little -1 of x. And this reads as inverse function. So when you see that little -1, you're thinking inverse, okay? Anybody seen that notation before? Or is this like brand new? Okay, you've seen it before. Okay. All right. So let's start with finding inverses numerically, okay? So numerically, if a comma b, so let's give those some colors. Let's say a is your x value and b is your y value. Okay, so let's say the point AB is on your graph of f of x. What that means is that the point B, comma A is a point on your inverse function. Okay. So what did we do there to the numbers? Yeah, they're swapped. We flipped the x and y coordinates. Good, okay? So when we want to find inverse functions numerically, all we need to do is switch our x and y, and that will give you the inverse. So let's try it out on these two examples. If I have the point 0, 1 on f of x, then what is the point on the inverse of f of x? 1, 0. Good, right? So all we're doing is saying that 0 is like the A, 1 is like the B, and so I'm just going to switch. So it'll be 1, 0 will be the same point on the inverse function. Okay. And we actually saw that when we were looking at e to the x, 0, 1 was a point on e to the x. And then when we found the point on the natural log of x, it was 1, 0. Okay. Now let's take a look at this one. If 3, 9 is a point on f of x, then what is a point on the inverse function? Nine, 3. Good. Very good. Okay. So same thing again, we've just switched the x's and y's, all right? So in this giant space down here, the note I want you to make for yourself is switch So we're going to say, let's switch x and y to find the corresponding point on the inverse function. Okay. All right. So that's it for finding inverse functions numerically. Super straightforward. You take your x's and y's, you switch them. That's it. Okay. So let's use that to take a look at this equation here. Okay. So now we're going to be looking at this graphically. If f of x and the inverse of f of x are inverse functions, then they are symmetric about the line y equals x. And so we're going to take some time to plot some points and draw that line and see where we go from there. Okay. So let's think about, if I wanted to look at example 3 here, I have f of x equals x squared. What are some good x values to plug in? Okay. 0, 1, 2. All right. That's it? We only plug in negative numbers? Yeah, maybe like trying some negative and some positive, right? Because we know what x squared looks like, but if we only plug in the positive ones, we're only going to get 1/2 of it, okay? So instead, we want to make sure that we see both sides of our shape, right? And these we can figure out pretty quickly. We've got 9, 4, 1, 0, 1, 2, whoops, 4, and 9, okay? And let's go ahead and plot these, all right? So let's do this in purple. So 0, 0, 1, 1, 2, 4, 3, 9, and then the points on the negative x. And if we connect these, okay, so this is our f of x. All right, now let's take a look at the inverse function, okay? So the inverse function, if you see way down at the bottom, there's a table. But in that table, I didn't give you an equation. So without the equation, how can I find the points on the inverse function? Just flip all the x's and y's. Okay. So that would give us 9, 4, 1, 0, 1, 4, 9, and -3, -2, -1, 0, 1, 2, 3. Okay. So let's think back to our earlier conversation. When we said, if you square something, how do you get rid of that square? Everyone said, oh, well, you take the square root, okay? And so the function that we have as our inverse function is actually the square root of x. That's how we get rid of the square, okay? Now, let's take these points on the inverse function, let's call them green, and let's plot them. So 0, 0, 1, 1, 4, 2, 9, 3. That gives us this part, okay? And then if we plot the other points, these ones right here, we would get -1, -1, 4, -2, okay? And so there'd be like this part down here. So if we just switch the x and y values, yeah, that would give us the inverse function, okay? But the graph that we know for the square root of x does not include this part on the bottom, the dotted part. Now, we did not include that because when we think about plugging in a 9 into here, this doesn't say plus or minus square root, it says positive square root. So what that means is this bottom half is not part of the inverse function. And because we have a positive square root, we can't get negative values out, okay? So sometimes when we're looking at our functions and inverse functions, we need to consider what happens with the domain and the range, okay? So let's go back to the purple x squared for a moment. What is the domain for x squared? Let me ask that question again. What's the domain for x squared? -infinity to infinity, okay? So we're looking at all numbers. I can plug in positive numbers, I can plug in negative numbers, I can plug in 0, that's all good. Well, let's take a look at the range for that. We know that the smallest y value is 0, and it goes all the way up to infinity. But since it includes 0, we have to use that square bracket, and we want to write that very clearly so there's no question about it. And then we need to close that with a parenthesis, okay? So that's our domain and range. Now, domain, we know, talks about the x values of a function or the input values, and the range talks about the y values, okay? So when we think back to what it means to find an inverse, we said, hey, let's switch the domain and range. So that means that the domain of the inverse function is the range of the original function, because we're switching x's and y's. Well, we could say that the domain is the x value of the inverse function, or the y values of the original function. Okay. Now, when we think about the range here, so is the range all real numbers for the green curve? Why do you say yes? Tell me more about that. So the question was, is the range of the green curve all real numbers? And yeah, I like your consideration that it doesn't cover the negatives. There's no green part below the x-axis. So our range is actually 0, infinity. Now this is the y value of my inverse. This is the y value of my inverse, or sum of the x values of f of x. Okay? So this is something that we need to be really careful about, is that sometimes when we're looking at inverse functions, sometimes inverse functions have restricted domains and ranges. Okay, so sometimes inverse functions have restricted domains and ranges. That means you can't take all of the x values and make them in the y values of the inverse, because right here we saw we couldn't get a negative number out, right? Now, let's go back and just check this symmetry, okay? So when we're thinking about symmetry, let's draw the line y equals x in there and then kind of go from there, okay? So the line y equals x is just a diagonal line right there. And we can kind of see, I think, that like this point we said was 3, 9. And look at this point. This is 9, 3. So if you turn your screen kind of diagonal, you can see that they're symmetrical about that yellow line. Or like this point is 2, 4, and this one is 4, 2. Well, if you switch the x and y values, then you get the corresponding point on the other side of that line, okay? So the symmetry part, I think, is a little easier to see, but what we need to be careful about is this restricted domains and ranges, okay? So if domain and range was something you were a little confused about in the last section, it's definitely not going away. So we want to make sure that we keep challenging ourselves to understand what domain and range stand for. Okay. All of this is to say that at the end of the day, it's still important that we can not only switch our x's and y's numerically and just flip things over the line y equals x, but that we also know how to find inverse functions algebraically. Okay? So here's a little how-to on finding inverse functions algebraically. So the way that we're going to do this, we're going to replace our f of x with y. Then we're going to interchange or switch x and y. And then we're going to solve for the new y, okay? So for those of you who like steps, this one is a very step-centered sort of piece. And you can use this as a chance to talk about restrictions on the domain as well, okay? So let's start with practicing this procedure on one that we already know the answer to, which is our f of x equals x squared, okay? So the first step it says replace f of x with y. And so instead of f of x equals x squared, I'm going to write y equals x squared. That's my first step. Okay. My second step says switch my x and y. So that's going to give me x equals y squared. I literally took the x and put it where the y was, and I took the y and I put it where the x was. And then my last step, 3, says solve for y and rename the function the inverse function. So if I want to get y all by itself, what am I going to do? I got to get rid of that square. So I'm going to square root both sides. Then the last step is we have to rename it. So we don't want to say y equals the square root of x, but the inverse function equals the square root of x. Okay. So that is the inverse function. But we need to talk about any restrictions on the domain. Okay. So when I think about the numbers that I can put in to this function, I can put 0 in, I can put positive numbers in, but I cannot put negative numbers. So when we write our answer, we want to make sure we include this domain part, okay? That it's like a 0 to infinity are the only numbers that can go into the function. All right, let's take a look at one where we're looking at a graph in addition to the equation, okay? So this graph, 5x cubed plus 1, okay? 5x cubed plus 1 is the one in the orange. So this graph is that graph. And if we think back to this idea of having the reflection, if 1 comma 6 is on the regular function, then 6 comma 1 is on the inverse function. And if 0 comma 1 is on the original, then 1 comma 0 is on the inverse. And we can see that these points make a really nice reflection over, they did green, but I'm gonna color over that with the yellow, that we are reflecting the orange graph and it will give us the blue graph. And so let's figure out how in the world they got this equation, like where did it come from, okay? So let's follow our steps. First step, I replace f of x with y. Okay. Second step, I switch my x and y. So I get x equals 5y cubed plus 1. Last step, I solve for my y. So what do I do first? What do I move first? Okay, so I have that 1. So I'm going to go ahead and subtract 1 to both sides. I'm going to get x minus 1 equals 5y cubed. What's my next step? Divide by 5. You got it, Christina. Whoops. So I'm going to divide both sides by 5. I've got x minus 1 over 5 equals y cubed. And my last step we talked about earlier, how do we get rid of that cube? Well, we cube root both sides. So we'll get y equals the cube root of everything on that side. Now, I think it was Natalia who had said you could also write that as x minus 1 over 5 to the 1/3 power, right? So the cube root and the power of 1/3 are the same thing, okay? But if you boxed off your answer at this point, I'd be like, so close. What is the last thing I need you to do in this process? We need to make it f to the -1. Good. So we want to write the inverse function equals, and then I'll let you choose which one of these works better for you. But I do want us to know that they're the same. Okay. So at this stage, you can box off your answer. All right. Now, I know this is a complicated looking function, but let's think about what kind of numbers we can put in for this x, right? Can I put positive numbers in for x and get a number out? Like, can I put x equals 2? Does that work? Yeah. Can I put x equals 3 or 4? Okay. Can I put in 0? How come I can't put in 0? Oh, okay. Well, so let's say I put in 0. I'd have the cube root of 0 minus 1 over 5, which is, let's see, -1/5 to the 1/3 power. Just try that on your calculator for a moment. All right, Laura says it's not a domain error. Anybody else? Ah, okay. So this goes back to, like, you know, we learn a lot of rules in math along the way, but if this power, so if the power, no, if the root is odd, okay, if the root is odd, it's okay to have a negative number inside the root. Okay, and I think Ethan says it way better than I just did. Any odd numbered root can be negative. Okay, so this is okay. I can plug in 0, but that means that I can plug in any negative number too for x. Like, that's not going to be a problem, right? Because I can have a negative underneath the cube root. So in this case, our domain is from -infinity to +infinity. I can literally take every single point on the orange line and flip it to find a point on the blue line. Okay. And you can kind of see from this graph, right? It goes all the way to +infinity and it goes all the way to -infinity. It goes on forever and ever, all right? Now, I noticed on a couple of the test questions that some people drew graphs that were correct, but maybe their work didn't match the graph, meaning they would show me a graph like this that had a domain of all real numbers, or from negative infinity to positive infinity, but then when they were trying to figure out the domain, didn't go back to the picture to help them understand that, okay? So a lot of times I'll try and give you hints by like, hey, I want you to draw the picture because I think it's easier to tell what the domain is from the picture, okay? So definitely try and use all the different parts of the problem. All right. So let's take a look at one where we don't have a graph given to us, but let's sketch this graph, okay? So tell me about this graph. F of x equals x minus 2 squared minus 3. What shape is it? Or what's the parent function? It is a parabola. All right. Now tell me what that minus 2 does. What does that minus 2 do, folks? It moves to the right 2 units and it goes down 2 units, go down 3 units. Good. Okay, so we know we've got a parabola. We know we go to the right 2 and we go down 3. Okay. And that means that our new vertex is over 2, down 3. That's our center point. And then we can draw some points like that are 1, 1 from there, 2, 4, 3, 9. And we can get a pretty good sketch of our parabola. Okay. I appreciate you. It does. Okay, so let's kind of sketch this y equals x, or yeah, y equals x line in there so we know what we're reflecting about. Okay, but let's also pick a couple points and switch the x, y value. So this point was 5, 6. So what should the point on the inverse function be? 6, 5, exactly. So I am even going to go ahead and draw that in right there. This is going to be 6, 5. All right, now I've got this point here, which is 4, 1. And so when I flip that, it's going to give me 1, 4. Okay. And let's do a couple others. This point is 3, -2. So if I flip that, I'm going to get -2, 3. And this point, which is 2, -3. And when I flip that, I'll get -3, 2. Yes, Christina, that's a really good observation. We always reflect about that yellow line. Okay. Now, thinking back to when we just did the x squared. So when we did the x squared, we only took some of the points and flipped them over. And we didn't do all of them because that gave us values that we crossed out here in the green because we couldn't get a negative value out, okay? Do you guys think I should switch any more points, or do you think that's good enough? Well, let's try flipping a few points and see a few more points. This point, that gives 1 comma negative 2. So if I switch that one, I'm going to get negative 2 comma 1. If I were to connect all of these green dots, do you think I should have included that last point or no? No. Can you folks tell me a little bit more about why I should not include that last point? Okay, so I think Ethan is summarizing it in a way that he says, you cannot have multiple outcomes for a given x. All right, so if we notice what happened is we have this point and now we have a second point. So that's not okay. All right, we want to not have that happen. The other way you can kind of tell is if you know you have a parabola, you know your inverse function is going to be some sort of square root situation. And with a square root, we know that it kind of starts here and it goes up like that. So it doesn't kind of curve around the bottom like that. So that's another way that we could kind of tell visually that we shouldn't include that last point that I flipped. Okay, so I'm gonna erase that and I'm gonna erase that green part right there. Okay. But let's actually find our inverse function now. So let's take our f of x. We're going to replace the f of x with y. Right? Switch our y's and our x's. So x equals y minus 2 squared minus 3. And here's where I always feel like I'm selling things on those like home shopping networks. But in 3 easy steps, we can get y by itself. What's the first step? How do I get y by itself? Add 3 to both sides. All right, so x plus 3 equals y minus 2 squared. All right, next step. Square root both sides. Okay. Square root of x plus 3 equals y minus 2. All right, last step, folks. What do we do here? All right, we add 2 to both sides. Now, Laura, can I ask you to clarify? Do you mean, like, can I, after I add the 2, does it become this? Okay. Does everybody see what happened there? So this is a big no-no because the x plus 3 is underneath the square root, but our plus 2 is very much not inside the square root. So because it's not inside the square root, I can't combine the 3 and the 2, okay? But I do need to write this so I have my inverse function, f negative 1 of x equals, and then I'll have x plus 3, and then plus 2 outside of the square root. Now, if you were to tell me about the graph transformations, just looking at the square root of x plus 3 plus 2, from here, I think you could tell me that it is a square root function. What are the graph transformations? left 3, up 2. Okay, so left 3 and up 2. That means my center point should be left 3 and up 2. That's another way you can tell, I stop right there. That's where I stop switching all the x and y values for the points, and that's sort of the starting point for my graph, okay? So for better or for worse, all of these things connect to each other. All these concepts that we've been doing, the graph transformations. I know the square root one's a little bit scarier than the others, but it's really handy to know because then it helps us make decisions for future kinds of problems, okay? So when we talk about the domain for this inverse function, we could say that we start at -3 and we go all the way to infinity. Right? So that domain is definitely restricted. Okay. Any questions so far? I know domain and range is not everyone's favorite, but I do think it's really important to know. All right, let's do these last two problems over here, okay? So example 7 and example 8. These ones I'm less concerned about the graph, okay? So when you see questions that look like this one, it's okay if you don't know what that graph looks like right now, all right? So that's why there's no grid here. I want us to focus more on the procedure, okay? So the procedure, if we want to find the inverse function, is put a y instead of the f of x, right? That's our first step. The second step is you switch your x and y. All right. Now, this question, I think you can tell, it is way harder to get y by itself than the other one. Because there's not just one y, but there's two y. Okay. I definitely want to make sure that we understand this kind of problem. So let's go ahead and put a big star next to this one and a big star and a number next to number 8. Okay. So sometimes we kind of hope that like the last few problems are not going to be things that the instructor wants us to know, but I'm telling you right now, I want you to know how to do that, okay? So here's what we're going to do. We've replaced f of x with y, we switched our x's and y's. Now let's do this. We're going to cross multiply. Okay? So when we cross multiply, we're going to get x times y minus 2 equals y plus 3. Everybody see how I got that? I took the x and I multiplied it by the y minus 2, but what did I multiply the y plus 3 by? Yeah, I multiplied it by 1, right? So sometimes we like, that's a good question for us to ask ourselves is what do we multiply by? Now this was actually a common mistake that I saw on the test. Some people wrote out like they were going to distribute, but then when they did it, they forgot to distribute to the second term, okay? So if I distribute here, I'm going to get, and let's make that our next step, distribute, okay? So I'm going to get xy minus not 2, but 2x equals y plus 3, okay? So we cross multiply, we distribute. The third thing we're going to do is we're going to collect y terms on one side. And what I mean by that is any term that has a y, I want to move it to one side. And then any term that doesn't have a y, I want to move those to the other side. So I can see from here that I've got an xy and a y. And those are the ones that have the y's. And then I have this 2x and the 3. So I'm going to move all the yellow terms to one side and the orange terms to the other. So that's going to give me xy minus y equals 2x plus 3. So orange and orange, yellow and yellow. Now, you might be like, why is she just moving things around? Like, it looks so much more complicated. Well, here's why I wanted to get the y terms on one side by themselves. What I've done is created a situation where I can factor out the y on one side. So y parentheses x minus 1. And that's going to equal 2x plus 3. What does that make my last step here? How do I get y by itself? Divide by that x minus 1. Excellent. Divide to isolate y. So we want y by itself. We got to get rid of that x minus 1. So we'll get 2x plus 3 over x minus 1. Okay. Now, to write an official answer, we'd want to say the inverse function equals 2x plus 3 over x minus 1. Okay. All right, so we are going to talk about the domain for this one, okay? So the domain. Now, the domain for this one, it's important that we remember some things about fractions, okay? So off to the side, I'm wondering if you can tell me, if I have 0 divided by 5, what does that give me? 0, okay. What about 0 divided by pi? What does that give me? 0, okay. So anytime that I have 0 divided by a number, I'm going to get 0. There's one exception to this. What's that? Okay. What's that? So the one exception is when you have a number divided by 0. So if the bottom equals 0 or the denominator equals 0, that's going to be undefined. Okay. So when we're dividing by 0, if 0's on the bottom, that's a problem for us, okay? Now that helps us figure out the domain. What numbers can I not put in to my inverse function? There's one that's really obvious. Yeah, I can't put in 1 because when I put in 1, all of a sudden I have 0 in the denominator. So I know that x cannot be 1, okay? But let's think about where our inverse function came from. It came from an original function. So if there are any restrictions on the original, those carry over into the restrictions for the inverse. So what number can I not put into the original? Exactly, Laura. We can't put 2 in either. So this one is because we get divide by 0 in the inverse. Okay, so the x can't equal 1 because it gets a divided by 0 in the inverse. But x can't equal 2 because this gets a number divided by 0 in the original function. So we have 2 problem points here, the 1 and the 2. Eric, that's a good question. Why does it matter for the original? Because that's where it came from. So if there was no point at x equals 2, then there's nothing to switch to get the point in the inverse function. Okay, that's a really good question. All right, let me say that one more time. You have to go back to the original because if there was no point there originally, then there's nothing to switch the x and y's to get a new point in the inverse function. So you have to check the inverse and you have to check the original. So if we're gonna write our domain for this one, okay, this is gonna look a little messy, but we're gonna say from negative infinity to 1. That's part of it. This little symbol means in union with, or you can think about it like an and. From 1 to 2 and from 2 to infinity. Okay, so this says all real numbers except x equals 1 and x equals 2. That's what that says.
What's that little U again in between the domain? Yeah, that one.
So, sorry, my notes are terrible today. This is...
No, they're not. Don't worry.
Thank you. This is in union with.
Okay.
So like one part and the other part and the other part.
Oh, all right.
Okay.
Thank you.
Cool. No problem, Christina. Okay. So I'm gonna shrink this a little bit. All right. And I think one of the scariest things in math is just like putting your pencil to the paper and just trying something, even if you're not really sure. Like if there's a lot of confusing things, right? Like probably in this problem. But despite that, I would like you to try number 8, right? And with number 8, where I really want us to focus right now is these steps in the pink. So you're gonna cross multiply, distribute, collect your y terms on one side, factor out the y, and divide to isolate the y. Okay, so I'll give you a couple moments to do that. And you can also start to think about the domain. What are some points that don't work in the domain? Okay, so let's take a couple minutes and work through number 8, and then I'll start to put my work on the screen as well. right. So I'm going to zoom in on 8 so we can see that one a little bit better. Okay. So all I've done so far is replace f of x with y and switch my x and y, right? So that first step, what did we do again? We cross multiply. Okay, so that's going to give me x times y plus 5 equals 3y minus 1. Okay, so we cross multiply. And then what do we do? And then we distribute. Good. Now we really want to be careful here, right? Everyone wants to make sure they get xy plus 5x and that they don't accidentally forget to distribute, even though they wrote the symbol. Okay, so that's going to be really valuable. All right, so we cross multiplied, we distributed. Now we need to get all those y terms on one side. Okay, so we know that we have this term with a y and this term with a y, and we have this one with an x and this one with no y. Okay, so what did people do? Anybody here move the 3y? How many people moved the 3y? Yeah. Anybody move the xy? So you can move either way. You just have to get all the y terms on one side and all the non-y terms on the other, okay? So let's do this. We'll do xy minus 3y. And what does that give us on the other side? If we're moving all the oranges to the other side. Negative 5x minus 1. Good. I really love that you didn't lose any of the signs along the way there. So this minus 5x and this minus 1. Okay. Good, Antonio. Good. All right. So let's bring it back up here. Step 4 is we got to factor out that y. That was our whole purpose. And so what we have left here is x minus 3, and that equals negative 5x minus 1. And then all we need to do is divide. So y equals negative 5x minus 1 over x minus 3. Okay. Now we want to be really thoughtful about our notation. So we don't want to write it as y. We want to write it as f negative 1. And we'll get this. Okay. Now, someone had said x couldn't be negative 3. Okay, so let's think about our domain right now. What are some values that x cannot be? So x cannot be negative 3. Why can't it be negative 3? Okay, why'd you change your answer? Yeah, from negative 3 to 3. Okay, so that's exactly what it is, folks. We need to think, okay, what number is going to make this 0? Okay, and if we plug in negative 3, it's actually fine. I mean, it gives us a negative 6, but that's fine. It's not a 0. So 3 is a number we can't put in, and that comes from the inverse function. But I'm really glad, yes, so we're solving the denominator equals 0. Okay, that's what we're really doing. If we say x minus 3 equals 0, what is x? Okay. Now we do have to go back and do that same thing for the original function, right? Because like Eric pointed out earlier, we have to make sure that we only switched points that actually existed in the first place. And so if we go back and say, what's going to make this equal to 0, then I think you'll get a -5 as that point, okay? Okay, so if we write our domain here, let's write it all out and then we'll take a look at what Eric said, okay? So our domain is going to be from -infinity to -5 in union with -5 to 3 in union with 3 to infinity, okay? And again, this says all real numbers except x equals negative, oh gosh, except x equals -5 and 3. That's what that long statement says. I feel like I was talking to a few of you earlier, and some of you said, oh, sometimes math looks like a foreign language. And yeah, it definitely does. And so knowing the notation is so helpful. But even when I take like advanced level math classes or whatever, I do this a lot for myself. Like if the professor's saying like all these weird symbols, like I will be like, could you say that in words again? And then I'll write it down so that I remember how to read it. And the more that I do that, then like at some point it becomes easier to read the notation for myself. Okay. So you shouldn't feel like, oh, that's a baby step that only like people who don't get it do. Like I think everybody should do this, especially if it's helpful. Okay. Now, Eric, let's go back to yours for a moment. You said that you moved the xy. So that means you got 5x plus 1 equals 3y minus xy. Is that what you got? Yeah, I think that's true. Yeah, because when you factor out that y, you get 3 minus x. Yeah. And then so you'll get the inverse function equals 5x plus 1 over 3 minus x. Yeah, that's the same thing. So if you have this answer versus the other answer, those are the same. So on an exam, I would accept either answer as long as the work that leads to your answer is accurate. Yeah, I mean, you can factor that out and and then distribute it to the bottom one and it'll give you the same thing. Like, let's say, I could multiply an equation by 1 and it'll still be the same thing. But let's say I call 1 like -1 divided by -1. Like -1 divided by -1 is 1. But if I distribute, I'll get -5x minus 1 over -3 plus x, which is the same thing as what we have. Okay. So either answer is fine. And I think with WebAssign, it should be the same thing. Either answer should be fine as long as all your positive and negative signs are appropriate. Okay. So, folks, that is the end of 3.8 for us. Okay. So I'm going to stop sharing the screen right here. And I'm going to